Hello, Algebra 3 class. See, I'm going to take you through lesson 2.1. So grab your notes. If you need to, we'll pause the video, but grab your notes and look for chapter 2.1. Chapter 2, we're going to get into, I think I skipped a page. That really skipped. Let me get back. All right, so chapter 2, we're working with equations this go around. This first screen talks about deciding if the presentation is an equation or isn't an expression. An equation has an equal sign. That's one of the main differences, right? It states that the left side equals the right side. Whereas an expression is kind of an incomplete thought, kind of like a sentence fragment, you could think of it as. So 9x equals 10. Well, I see that equal sign, so hey, this must be an equation. 9x plus 10, no equal sign. So that makes this just an expression. Again, I'm searching as I'm looking left to right. I do not see an equal sign. This is an expression. And D, obviously, we got the equal sign. It's saying the left side equals the right side. This is an equation. So they're fairly easy to discern, right? Next, we're going to get into solving equations, and your homework tonight is working on a Math Excel assignment, and it has a lot of equation solving. So first thing I'm going to do is simplify each side, pulling together like terms. So simplify each side. So like terms here, that's going to present through addition as 12x. On the other side, I see a 17x, and then negative 9 and a negative 1 make negative 10. Add those like negative numbers together. Next step, we want to get x's on one side, right? If you don't think you need these notes on the left, then feel free not to copy that down. I realize you guys have been solving equations for a while. So this intro of chapter 2 might seem a little bit easy right now. 12 minus 17 is a negative 5. 17x minus 17x, that's going to go to 0, isn't it? And then I'll bring down that negative 10. Next step for me is going to be dividing so that I can get to just a single x, 1x. So when I divide, it's the x side that I'm looking at. I'm going to divide by negative 5. On this left side, I'm going to get 1x. On the right side, a negative divided by negative is positive. 10 divided by 5 is 2. So 1x equals 2, but we know we really don't have to write the 1, do we? So our answer is going to be x equals 2. When you do Math Excel, they have some options, and one of their options is there is a solution, and the solution is, and then they'll have this box inside the braces. So the braces stand for a set, the solution set, and you're going to type into the solution set 2, okay? So just to let you know how that's going to operate on the Math Excel. They also will have option B, which might say there's no solution. And then I think there might be an option C where maybe it says there's many solutions. If we come out with one answer, then you want to put it into that set solution. This one, I would do some distributive. Remember how we talked about there's really a 1 sitting in front of here, and really it is negative 1 since it was subtraction. We're going to distribute the negative 1 through the parenthesis. So 6 minus 4 minus m equals 8m. And here I'm going to think of this as plus negative. So it's a negative 2 that I'm distributing through this time. Negative 6m minus 10. So we did distributive step first, just like order of operation, right? Do the parentheses first. Next, let's move to multiplication and division. I don't see any. Now let's put like terms together. Simplify those. So I'm going to pull this together. 6 minus 4 is 2 minus m equals, these are like terms, 8m minus 6m gives me 2m, and then I've got the minus 10. Let's separate things. Let's add. How do we want to do this? Let's subtract 2. And we know that that is going to go to 0. This will come down, won't it? I'll have negative m. This will come down. Really, I'm adding it with 0. So 2m plus 0 is 2m. And then negative 12. I want numbers on one side and letters on the other. So I'm going to subtract 2m from each side. And now negative 1m plus negative 2m gives me negative 3m. This goes to 0, and negative 12 will be on my right side. And finally, we're into the division step. Let's divide by negative 3. Negative divided by negative gives us positive. It's really a 1, isn't it? But we don't have to write 1. M equals 4. For this one, I might try to get rid of these awful denominators. So I think I'm going to do that. In order to do that, I can multiply by the number that they all go into. So I'm multiplying by the least common multiple. And to me, if I have the numbers 2 and 4, well, they would both go into 4, wouldn't they? So 4 becomes the least common multiple for them. So what I'm going to do is multiply every term by 4. And as long as I do it on each side the same, I haven't really changed the problem. I've kind of scaled it up, but I've scaled everything accordingly the same. So now 4 divided by 2. 4 divided by 2 leaves me 2. And I'd have 2 times k plus 1. 4 divided by 4 leaves me 1. So I have k plus 3. I'll throw that 1 out there just so you can see that we talked about it. And 2 goes into 4 twice, so I end up with a 1 times a 2. Now let's simplify. So here we multiplied, and here we're simplifying. And distribute as part of that simplifying step. So I get 2k plus 2. Let me move this up. 2k plus 2. Really, 1 is insignificant, so that's a k plus 3. And 1 times 2 is 2. Now let's go for those like terms. Adding like terms, I'm going to pick up the k's together. That'll give me 3k. And I'm going to pick up a 2 together with this 3, right? And the numbers pull together. So I'm going to get a 5 equals 2. Now let's solve for k by getting it by itself. So I'm going to subtract 5. And that's going to give me 3k equals negative 3, because 2 minus 5. And then we're into division step, divide by 3. K equals negative 1. Sometimes it's nice to multiply by the reciprocal. So that would be like if I have 5, I'll multiply it by 1/5, right? And that'll give me 1. That's that multiplicative inverse property. No, multiplicative identity. No. Oh gosh, you guys. It's inverse because it gives us 1. Multiplicative identity is when you multiply by 1. Here we're multiplying by the inverse, 5, and its inverse is 1 divided by 5. That'll yield 1. So I'm going to take this and multiply by its reciprocal. All right, so we have this negative 5/9. Why don't you write a new statement down here, just so we have some space to work on. I'm going to take this and multiply it by negative 9/5. The reciprocal, right? Compare those two. The reciprocals of each other. So if I do it on one side, darn well better do it on the other, right? What do we see happening here? Well, the 9 cancels with the 9, or 9 divided by 9 is 1. 5 divided by 5 is 1. Negative times negative is positive. So I end up with k on this side, really 1k, but we don't usually write the 1. And on the other side, this is like over 1. So I'm going to multiply my tops together and get negative 18. And then I'm going to multiply my bottoms together and I'll get negative 18/5. And that's the answer. So some of these can be a little bit difficult, can't they? For this one, I'm going to multiply by the least common multiple again. And with 4 and 6, I'm thinking they both would go into 12, right? 12 will be my LCM for this problem. So I'm going to multiply by, let's just rewrite this problem because I need more space to put a number out front. Maybe on yours you're fine, but I'm going to rewrite. So I'll show you what I'm going to multiply by. Every single term is going to get multiplied by that LCM. Do you have different colors of pens? You know, it could be helpful in your notes to use those. It makes it stand out what you're doing. All right, now 12 divided by 4 is 3. 6 goes into 12 2 times, and then the right side is fine, isn't it? Now I'm going to distribute. So I'm going to have the 3 times 3x minus 1. I'm going to have 2 times x plus 3. Let's go ahead and multiply that. That gives us 36. 12 times 3, 36. Distribute. So 3 times 3 is 9x. 3 times negative 1 is minus 3. Distribute again. 2x plus 6 equals our 36. Now it's about gathering like terms, isn't it? So the x's can come together. I see an x here and x is there. So that's going to give me, what, 11. I almost said 7. 11x. Now look for your number pieces. I've got a negative 3 and a positive 6. So that'll be a positive 3 equals 36. And now solve. Solve for x. Now you're down to a nice little two-step equation. Let's use a different color. Subtract 3 from each side, right? We want x's on one side, numbers on the other. This 11x adds with 0 to give me 11x. We see that this goes to 0. And 36 minus 3 is 33. In steps the division step. So we can get rid of the 11 and bring us down to 1x equals 3. Or we could say x equals 3. Oops. Sorry about that. All right. Hopefully that you got. Some things solve equations, decide whether it's a conditional equation, an identity, or a contradiction. Well, what does that mean? A conditional equation has one answer. That's our typical, what we've been doing so far, x equals 5. An identity will come out looking like 5 equals 5, or 0. Really, if you take it far enough, you're going to get 0 equals 0. So that's probably better to write in. A contradiction is going to be just what it says. It's going to be not true. That might seem weird in here. It's going to look like 0 equals some number, maybe 5. And when we analyze that, we're going to tell ourselves, oh, this is not true when I get done solving. So that's going to be known as a contradiction. It contradicts itself, right? Alrighty, so let's do this one problem. How many are? That's it. There's just these 2 to go, and then we're done. Start off, distribute through. Be careful with this second one. We'll talk about that. So we get 5x plus 10. I'm thinking this is plus negative, so it's a -2 that I'm distributing. That'll give me minus 2x minus 2 equals 3x plus 1. Pull together like terms on the same side. So 5x and minus 2 gives me 3x's. And then I'm noticing the number part. 10 and a -2 can come together. And that would make 10 minus 2 is 8. On the right-hand side, it's just nice, simple 3x plus 1. So I'll just rewrite. Let's subtract 3x. And we know that that's going to go to 0. And we'll have the 8 equals, oh, another 0 there. 8 equals 1. Well, that's not really true, is it? That is not true. And therefore, it's what we refer to as a contradiction equation. Sorry about the blackout screen, you guys. Okay, so this is a contradiction. Which means there's no solution. Where am I right solution? Right here. Yeah, when you hit that contradiction, really what it's telling you is that this equation that they started us out with was bogus. This is not equal. The left side can never be equal to the right side. I can try as hard as I want to find an x value to plug into this thing, and it's never going to work out. So that's a contradiction. It means no solution. And then let's try this last one. Gotta love these ones with the fractions, huh? Or not so much. You know what? I think I'm going to skip B just for time-wise because I'm looking at the clock. I want to keep this around 20 minutes. All right, so we're going to distribute. Let's do C, and then when we get back on Monday, I can finish up B for you. 15x plus 5. Maybe a little higher would be good, huh? All right. Get that so you can see it better. And that equals x plus 5. Let's subtract an x. And now I'm down to 14 of them. 14 x's plus the 5 equals the 5, because we know that this zeroes out. Subtract the 5. Let's see what we end up with. There's that 14x equals 0. Now if I divide by 14, I get x equals 0. Could that be right? Well, it is, you guys. 0 is just as good a number as 1, 2, 3, 4, 5. So that is your answer. You could check it and see if it works. So if I plug in 0, 3 times 0 is 0. Put in 0 here. This side I have 5 times 0 is 0. 5 times 1 is 5. And this side, 5 plus 0 is 5. 5 equals 5. It's a solution. Yeah, this is good. It's not a no solution. It is a solution. All right. Homework is my math lab, or no, my math Excel, and you can work on that right now. Have a good weekend.